All right, so let's finish up this lesson. We didn't even get halfway through it, so we got a little bit to do today. So I want you to stay awake. I want your head up off the desk. You should be writing. Everybody should have a pencil or pen in their hand, and you should have your notebook out in front of you and should be taking notes. All right, so I'm going to call this 1.5b because this is the second part to 1.5. All right, so I'm not going to review what we did yesterday. Let's just go on to the new stuff. The first thing is called congruent. That's a word that you're going to hear a lot, a whole lot in geometry. It's the first time you've heard it in here. Okay, then now please with the pencil. Where's your paper? You should be writing something down. Okay, I just asked. Everybody should have something in front of them. I don't know why I have to call you out personally, but I did. All right, come on, be students. All right, let's wake up. Let's snap out of the laying back, being too cool for everything. All right, let's sit up, let's pay attention, let's be good students. There's nothing cool about slouching. There's nothing cool about not taking notes. All right, let's get an education. All right, that's what I'm here to teach you how to do. All right, so you should have notes out, you should be writing stuff down. All the stuff I write up here, you should be writing down. And maybe I say something else that I didn't write down you think is important, then write that down as well. All right, let's talk about this, congruent. Congruent kind of means equals. It kind of means equals, all right? So we have a symbol for congruent. Here's the symbol. Let's just put it right here. Since it's kind of like equals, it has an equal sign to it, but it's got one extra little thing. It's got a little squiggly thing on top of it. Everybody see that? All right, that's the symbol for congruent. So if I say that the segments are congruent, later on in another chapter, we're going to talk about triangles being congruent. We're going to talk about polygons being congruent, all this kind of stuff. All right, that's the symbol that we're going to use right there. That's a congruent symbol. Penny, where were you? Where were you? Came in 10 minutes late. Did they give you a pass? Did you ask for a pass? You should ask for a pass. All right, you can't just come in and just walk in whenever you want. I got to know where you were and that somebody else knows where you were. All right. Here we go. Let's keep going. Let's try to teach some geometry here. This means congruent to each other. So when we talk about segments, we've talked about what a segment is, right? A segment's got two endpoints. It does not keep on going. You can measure a segment. We did that with the number line, right? We went from point A to point C. We measured how long it was. That's what we did in the last lesson. But let's say I did this. There's a segment right there. Now with this computer program, it's kind of nice because I can make that exact segment. On this computer program, how do I do that? How do I make another segment exactly like it? Copying and pasting. You know what the keyboard shortcut for copy is? Control-C. Good. So I can hit Control-C, nothing happened. Well, it actually did inside the computer, but it doesn't look like anything happened. Then I hit Control what? V. Why V? Because it is paste, but why did they make it V? Why do you think they made it V? Why didn't they make it Control-P for paste? Anybody know? It's closer. It's right next to it. Very good. The V is right next to the C on the keyboard. Okay. So I hit Control-C already. Hit Control-V. Boom. It puts it right there, and I can move it around. I can even turn it. Right now, look. I'm moving this thing right. It didn't make it bigger or smaller. It just turned it. So, what about the length of this line segment compared to the length of this line segment? I copied and pasted. And I didn't stretch it out or anything like that. So tell me something about the length of those two line segments. They're the same, okay? So when you have the length of two line segments are the same, what do you think we call those? Congruent segments, exactly right. So these are congruent segments. So let's label it. Remember, they have endpoints, so we're going to name this segment by its endpoint. So I'll call this AB, line segment AB, and I'll call this CD, line segment CD, all right? Now, if I didn't tell you that I copied and pasted it, would you be able to look at it and tell me 100% that they're exactly the same length? No, you wouldn't, okay? Now, it looks like they are, right? But I don't know if they're exactly the same length. But I did show you that I copied and pasted, so yes, they are the same length. But if this was on a piece of paper, you could not say that they were congruent segments because you don't know for sure that they are congruent, all right? Here's a couple ways to see, like if they put it in the book, how do I know if they're congruent to each other or not? And you have to. You can't just guess, right? You got to know exactly that they're congruent, right? and here's OA. Let's make this a different color. If they do this, I said this earlier, and you looked at me like, what am I talking about? Because I haven't told you this yet. It's called a tick mark, T-I-C-K, all right? I think it's T-I-C-K, right? If they put a little line right here and a little line right there, if this has one tick mark and this has one tick mark, what do you think that tells you about those two line segments? Well, it's not necessarily the middle. Okay, we will talk about that later on, about being the middle. What is it? It's not where they meet, because they don't meet each other. Okay, because they're line segments. They start and stop. They do not meet each other. Evan, what'd you say? They're the same size. So that must be, it must mean they're what kind of segments? Congruent segments. That's right. Okay. So if this doesn't have to be dead in the middle. All right. I just put it in the middle. A lot of times they do. All right. It doesn't have to be dead in the middle. But if I put a little mark here, a little mark here, that means that those two segments are exactly the same. So if they do that in the book, you can look at it, you can rest assured that those two segments are equal to each other, or congruent. Okay, we say congruent to each other. They have equal lengths, but the segments themselves are congruent. It's a subtle difference, but that's what we got. Donnell. Not really. Most of the time, they kind of put them in the middle, all right? But like if I had it up here, like, let's do this. Oops. If I put a tick mark right there, it's still got one tick mark. Okay, so it doesn't have to be like exactly in the same place. Everybody with me on that? Oops. Let's do that. Let's put that right there. All right, normally we put them in the middle. Okay, it doesn't have to be. All right, what if I did this? What if I put a couple other line segments here? Let's scooch this down a little bit. All right, what if I put one, I don't know, like this? Let's make it quite a bit bigger, all right, so that we can see that they're different. And let's just name them again. We'll just go, let's go P and Q this time. Let's go PQ. What's that? Element of P, Q, RS, right? I'm almost 60 years old. I still got to do that to know the order in the alphabet. All right, let's take a look at this. Now, again, if you just saw this on a piece of paper, do you know 100% that they're congruent to each other? No, you don't. All right, so what could we do? Put a little tick mark. But look, these two right here are congruent because they have one tick mark. Would I put one tick mark here and one tick mark here? Because if I put one tick mark, guess what that means? All the things with one tick mark are congruent to each other. So that's probably not a good idea, is it? To put just one tick mark here. So what do you think I'm going to do to show that these two are different than these two? I put two. Good. Okay, I put two tick marks. So like that. So if you take a look at this, just by looking at this picture right here, you know that the ones with one tick mark are congruent and the ones with what? Two tick marks are congruent to each other. Everybody with me on that? All right, it's an easy way that you can see, and they'll do that on a lot of these problems. They'll do it on some examples and things like that. So you know exactly which ones are congruent to each other. Here's another way to show that they're congruent to each other. They could say this. If they didn't, let's do this. Let's get rid of the tick marks. So let's get rid of this one. Oops, what did I just do? All right, let's do this one. Let's get rid of these. Let's get rid of these. All right. Here's a second way to show that these segments are congruent to each other. Okay. A lot of times they'll use the word given. I really don't want to be in red. Let's go back to white. All right. You'll see this. It's very, very common in geometry. You'll see given. So this is the stuff that they tell you about the line segments. You can't just look at them and tell right now that they're congruent to each other or anything else, okay? They have to tell you. So they could tell you with the tick marks, or they could tell you like this. They could say that line segment AB is congruent to, what's the symbol for congruent? That, yeah, this equals with a little squiggle on top. That's the congruent symbol. So you could say AB, line segment AB is congruent to what? Yeah, line segment CD, all right? So that's another way that you could tell that they are congruent to each other. So if they tell you this, then you know that these are exactly the same length, okay? Are they the same line segments? No, they're different line segments. This one's over here, it's slanted this way. This one's over here, completely different line segment, right? And it's slanted a different way. Even if they were slanted the same way, they would still be two completely different line segments. So we don't say that they're equal to each other, right? We can say that their lengths are equal to each other, right? But we don't say the line segments are equal to each other. We say that they are congruent. That's the difference between equal and congruent. Equal means they're the same exact line segment. Congruent means that they're two different line segments, but they have the same length. You hear me on that? That's pretty important, okay? Because a lot of people get confused on that. What could we say about those two longer ones? We could say it's given that what? Okay, let's not just say PQ. What is it? It's what is it though? It's a line segment. So say what? Line segment PQ is congruent to. Good. Now, does it matter if I call this AB or BA? Nope, doesn't make any difference. I could call this CD or DC, doesn't make any difference. I could have called this QP, I could have called this SR. That doesn't make any difference, all right? But the P and the Q have to be the endpoints, all right? Everybody with me? So those are congruent segments. So that's really, really important because we're going to be doing that a lot. Okay, now we're going to do an example. I've been harping on this almost since the first day we started teaching stuff. Remember we did all that algebra and I said, this is why we're doing this algebra. Why are we doing this algebra? Because you're going to do what? You're going to see it where? In geometry. Guess where we are? In geometry, and you're going to see some of that algebra, okay? We did a little bit yesterday, right, with the adding and subtracting negative numbers. Okay, we did a little bit of that, but now we're actually going to do some algebra in our geometry class. This is where I wanted to end up yesterday, but with the fire drill and all that kind of stuff, we just couldn't. I'm gonna do this first. I'm gonna start off super easy at first, and then we're gonna do the algebra. All right. Let's say here's a line segment. I got a point right here, somewhere in between those two endpoints. What if I put a 3 right there? Let's do this. Let's say that's A, B, and C. What does that 3 mean? If you looked at this picture right there, and you saw A, B, C, and you saw 3 sitting right there on top, doesn't mean that there's 3 points. It's a good guess. What is it? Heard somebody say something. What do you think that 3 represents? No tick marks. Remember yesterday we talked about the length of things, right? The number line kind of stuff. So what do you think that 3 represents? 3/4? It could be inches. We don't know. I didn't put it inches or feet or anything. But you're on the right track. What if it was 3 inches? What does that mean? The length of. That's what I was looking for. The length of line segment AB. Everybody see that? Yeah, it's between A and B. That's how long it is. Okay. I didn't put the little tick mark, or the little marks where you go 1, 2, 3. I just put a 3 there on somewhere in between A and B. That means that. I'll tell you what. Let's get rid of that thing. We'll go inches. That's all right. 3 inches. Okay. Let's say this was 5 inches. So what's equal to 5 inches? If I put 5 inches on top right there, you tell me what segment in this picture right here is actually 5 inches long, if you were to measure it. B to C. B to C. That's right. Okay? Everybody see that? So if it's just between the A and the B, it doesn't have to be on top. They could have put it right here. All right? It doesn't matter. All right? But it's somewhere between those 2 points. That means that that's how long that line segment is. And BC, I'll tell you what, I'll just put that underneath. So it's, in the same place with the A and B. If you wanted to, some people do this. Some people say, oops, it's not what I wanted to do. Some people do this, and there are times where that's helpful. See what I did right there? So the arrows means it goes to what? It goes from A to B, all right? I could have done the same thing here, but you don't really need them, all right? So I'm going to get rid of them. What if I asked you, what if I asked you to find AC? What does that mean? Just AC, sitting there by itself with nothing on top of it. Sincere? Speak, I can't really hear you. Well, what does it mean? What does the AC mean? If it just says find AC, what is it asking you to do? We did this yesterday. This is what we did yesterday. Ben, this is your seat right here. Quick, do it quick. Grab your stuff. It's right here. Go ahead. What were you saying, Simon? That's it. Exactly right. It's the length of AC from A to C. All right? So you do the math. Look at it. What is AC? That could be a quiz question. It could be a homework question. It's 8. That's right. What did you do? What math did you do? You just did 3 plus 5. That's right. So if I wanted to show my work, I would go 3 plus 5 equals what? 8. If they give you units right here, then we put the units in. All right? And that would be your answer. Everybody with me on that? What if they did this? I'm going to get rid of the inches. Is that all right? Just kind of gets in the way. All right. I'll keep that 3. All right? What if I don't know this? I'll call it X. But what if they tell me what AC is? So if they tell it to me, a lot of times they say given. All right? I don't know if they do it on this lesson, but eventually they'll say that a lot. Right? So given that AC equals, let's make it 10. All right, there you go. So you got to solve for X. What is it? How'd you get 7? What is it? Okay. I would go, right, subtract 3 from 10. Exactly. Because what is AC? AC, watch, I'm going to do this little thing. All right, so that whole thing right there is how much? That's 10. A to C is 10 because they told you. A to B, they kind of told you because they put it on the picture, is 3. So you got to find this. So what do? You take 3 away from the whole thing, and you're going to get what's left over. Correct? So here's your work. 10. It's not much work. I mean, everybody could do that in your head. But 10 minus 3 is what? 7. So X is what? 7. Right with me? Okay. Now, that really wasn't algebra, but it's going to kind of lead us up to the algebra. So hopefully you understand that part. So AB plus BC equals AC. Do you hear me? All right, so this little bit right here, AB, plus this bigger bit right here, BC. If I add those two together, I get the whole entire thing. You got it? That's super important, what I'm saying right there. I know you don't realize how important it is, but I'm trying to tell you. All right, so here we go. This is an example in the book, and it's example 2 in the book. Let me draw the picture. It looks very similar to what we just did. And they put points right here. Call that A, call that B, call that C. Now, this is a little different, so watch. Remember on that last one I put an X there? This one, they say this is 6x minus 1. So what is 6x minus 1? What are they telling you is equal to that? AB, that's right. This little segment from A to B is 6x minus 1. Everybody with me? Okay. And they also kind of tell you, now why do they kind of tell you AB? Because you don't know what X is, right? It all depends on what X is, on how long AB actually is. So they kind of do the same thing with BC. So they put a 5x plus 10 on top of that. Now, with just that information, you would not be able to solve for X. Here's what they tell you. They say if. They don't use the word given. I'll tell you, I'll write it right here. So they say find AB and AC, and then they say if AC is equal, I'm sorry, this is BC. I was going to say, they tell you what AC is, so why would they ask for it? I'm sorry, that's BC. All right, and if AC is equal to 75. All right, so this is the problem. This is something that you're going to see on a quiz, you're going to see on a test, you're going to see in your homeworks. Okay, so make sure you write this down and understand how to do this. Just like we did before, what's true about AB and BC compared to AC? What if I do, what can I do to A, B, and B, C to get the whole thing? Now, it's not half. I never said this was halfway, did I? So we're not saying half, right? But I remember I had that 3 and that 5. That 3 and that 5 added up to be what? 8. So what are you going to do with these? Watch. This whole thing, what did we say AC was? 75. So that might help a little bit. So what do we do with those two things? What do I do with that 6x minus 1, and what do I do with that 5x plus 10?
Oh, you got to do 6x minus 1 equals 75.
No, it doesn't equal 75. Because remember the one we did earlier with the 3 and the 5? We didn't say 3 equals 8, did we? What did we do to that 3 and that 5? No. When this was a 3 and this was a 5, we added them up, right? And we got the whole thing. So what are we going to do here? You're right. Yeah. But we're going to write it down. What do we do with this 6x minus 1 and that 5x plus 10? What is it? Yeah, add them up. You add them together. That's right. And what do they equal after I add them together? No. They equal what? There's a number. 75. Right. They equal 75. Look, this little bit right here and this bigger bit right here add up to be the whole thing. Hear what I said? The small bit, the medium bit, we'll call it, add up to be the whole thing. Okay? So what's the smaller one? 6x minus 1. And then what do we do to this part right here? We add it. Okay? So I'm adding those two things together. Once I add them together, what's the whole length of this? They tell it to me. They tell me the whole length. It's 75. So this stuff right here added up equals what? 75. That's what I consider your first real geometry problem, okay? This is the kind of stuff that you're going to do the rest of the year. Not the same exact problem, but you're going to give a picture. They're going to put some values in there. A lot of times they use X's, okay? And just like they did here. And they might tell you the whole thing or something like that, okay? And you got to put it together, make an algebra equation out of it. That's what we did right here, isn't it? We took the geometry. This is the geometry right here. We took the geometry. We said, okay, those two segments add up to be the whole entire thing. So that's what we're going to do. We're going to take that segment, this segment, we're going to add them together. And when I add them together, what does it equal? The whole thing. They tell me the whole thing, right? And it's equal to 75. I can't stress to you. I know I keep saying this all the time, but this for real. This is like, if you can understand this and get used to this, what we just did right there, take that picture and then make an algebra equation out of it, that's what we're going to do the rest of the year. But we're going to do it with different shapes, not just line segments. We're going to do it with angles. We're going to do it with all kinds of other things, okay? This is so important that you understand this. So if you don't, you got to stop me. You got to say, man, I'm not Mr. Hammer. Where'd you get that 75? Why did you add them up? Ask me that stuff if you don't know how, all right? I think I explained it fairly well, don't you? Especially with the 3 and the 5. Agreed? Right? Remember, if this was 3 and this was 5, what do? They add up to be the whole thing, which is 8. In this case, it's not 3, 5, and 8. It's 6x minus 1 adds up to 5x plus 10, and they add up to be the whole thing. They tell me the whole thing, right? Because it says if AC is 75. They tell me the whole thing, so I do that. Now, I can do what we did a week or two ago, right? And do some algebra. This is why I taught you all that algebra before we even started geometry, because I knew that you were going to get to this stuff. Yeah? Okay. I know I keep repeating myself, but I want you to understand why. All right, let's do this. All right, let's just add them up. 6x, let's add up some like terms. What do I got? 6x plus 5x. Abdul, you already said it earlier. You saw it right away. What is that? 11x. Good. So this one and this one add up to 11x. Let's add some other like terms. I got a negative 1 plus 10. What's negative 1 plus 10? Plus what? 9. Make sure you put the plus there because it's positive 9. And that equals what? 75. Okay? See all this algebra coming back to you? That's why it's important, right, to make sure you know how to do that stuff, because You're going to have to here. All right, what do we do here? Now we got to get 9, right? Let's move 9 over to the other side. And that's 66, right? That cancels. I got 11x equals 66. Yep, you see it right away, don't you? See how it starts just kind of snowballing, right? At first, you're like, okay, what do I do first? And then you're like, oh, okay, now I do this. Now I do this. That's what I always liked about algebra. That cancels. X equals what? 6. Now, is that my answer? Is that what they're asking me to find? No. What are they asking me to find? AB and BC. So how do I find those two? That's it. Plug the 6 back in for the wherever the x is. Okay? So that's what I'm going to do. Since x is equal to 6, now I can figure out what that is. So watch. I'm going to put 6. I'll just write it down. 6x minus 1. All right? Let's figure out what that's equal to. So what do? 6 times 6 minus 1. Where did I get that 6? Because x is equal to 6. All right? The first 6 was just in the little formula there. What's this? 6 times 6 is? 6 times 6 is 6? Oh, okay. I didn't hear you. 6 times 6 is 36 minus 1 is what? 35. So what's equal to 35? AB. So watch what we do. I write AB equals 35. Why did I write AB with no line segment over top of it? Because what did I just find? I said this earlier. The length of. That's right. I found the length of AB. That's what they're asking you to find. The length of AB and the length of BC. So I can circle that. That's one of my answers. I'm not done though. I got to do one more thing. What do I got to do? Plug it back in for this. Now watch this. There's another way you could do it that's actually a little easier instead of plugging the x back in. Now you could. Let's do it. Let's plug the x into this. So what is it? 5x plus 10. So it's 5 times 6 plus 10. And that's 30 plus 10. And that's what? 40. So that means BC equals 40. There's an easier way. Once you found this, what was this length AB? It was 30. You got it. Okay, you see it now. Do you see that? So once you get one of them, right, I could have found this to be 40 and then subtracted to get 35. Or I could have found this to be 35, subtracted from 75, and to get 40. So that's another way to do it. You don't have to do it both ways, but it's an easier way. So if I know the whole length is 75, I could have just done what? 75 minus what? 35, and that equals 40. Okay, and so that's 40 right there. Right? Either way you do it is fine. Right? You could have done it that way, or you could have done it this way. Yeah, once you solve one, usually, not all the time, that doesn't always happen, but in this situation it did. Yep, if you solve for one, then the other one, you just take it away from the whole thing. In this problem though, okay, it's not always like that. So what do you think? That's your first real algebra stuff that you did in a geometry class. You okay with that? Aren't you glad we went over the algebra? Yeah, all right. Let's move on, all right? I'm not gonna take any more time on that. If you didn't get it, make sure that you watch the video again. Okay, just watch that little part right there. You don't have to watch the whole entire video, but at least watch that one part right there. All right. So somebody said on the other one they talked about the middle of it. I'm like, nah, that doesn't mean it's in the middle. Oops, I knew that was going to happen. Now it won't happen. Okay. So I've got a point. We're going to call this x and y. Now watch very carefully. I'm going to put something on here that we did earlier. All right. By the way, I forgot. Let's call this. Let's call this M. Call that point M right there. All right. And watch what I'm going to do. Everybody watching? Okay. Write this down. I'm going to put a little tick mark right there, and I'm going to put a little tick mark right there. What does that tell you about xm and my? What is it? Yeah, but let's not say that just yet. That is true. You are right. They're the same length. xm and my are the same length. So that means they are what to each other? Give me congruent to each other. That's right. So just me putting those little tick marks right there, that tells me that xm is congruent to my. Yes? Okay. Now, go ahead, Alani, tell me. That means that m is where? In the middle. It's dead in the middle because there's just as much room on one side as there is to the other side. You follow me? It's just as the length from m to x is exactly the same length from m to y. So that means m is in the middle. But we don't call it the middle. We call it a point that's in the middle, but we give it a name, all right? And we call this, let's do this. Let's go back to weights. Now, it's not the vertex. We call this point that's in the middle, we call it the mid, what do you think? Point. The midpoint, okay? So it's the point that's in the middle, all right? So middle's fine, but we don't say it's in the middle. We say it's at the midpoint. So the midpoint means that it's basically in the middle. You got it? Which means what? That xm is equal to what? My. So the length of xm is equal to the length of my. Or you could say it like this. You could say line segment xm is congruent to line segment my. It's a subtle difference. A lot of students don't understand the difference between them. This just means the length of the two segments are equal. This means that the line segments themselves are congruent to each other. All right? So there you go. So that's enough about, so for instance, let's just do a little example here. All right, so what if I told you that xm was 3? That's all I told you. But I told you that m is the midpoint, okay? So if I told you that m is the midpoint and this little thing is 3, I want you to tell me two things, all right? I want you to find, let's do this. So here's a question they could ask you. Find my and xy. What does that mean when it's just my by itself and no line over top of it? Find the what of it? The length of my. Okay? So let's find the length of my. What would it be? It'd be 3, exactly. Because if you know that this is the midpoint, right? You got the tick marks there. If this is 3, then this is 3. Some of you guys are dropping out on me. Okay? You guys are doing so well. All right? We're getting to important stuff here. So stick with me. All right? So what is my then? My. My is 3. So I'm going to write my is 3. Now I need to find xy. So xy goes from here all the way to there. That's easy. I already said it, Zion. What is it? It's 6. So from here to here is 3. Here to here is 3. So the whole thing is what? 6. Okay? What if I told you this? What if I said that it was given that xy equals 10, and I ask you to find xm and my? Yep, you got it. Just divide it by 2 because these are the same length. How do you know they're the same length? Because of the tick marks right here. Okay, that means m is the midpoint. So if the whole thing is 10, then these two parts right here have to be half of 10. So half of 10 is 5, and this is 5. And then you would just write that down. xm equals 5, my equals 5, and you're good. All right, enough of that. Let's go on. We got to move quickly because I'm running out of time. I always ask every time. It is 10 of. Okay, I was pretty sure. So we got about 11, 12 minutes. I don't know if we're going to get through all of it, but at least we can do a little bit more. The other day we talked about angles. Remember angles? All right, angles are made up of 2 what? And one angle is made up of not 2 lines, 2 what? What are these 2 things? Here's the end point. They're rays. They're rays, okay? So an angle is made up of 2 rays. Everybody got that? So let's just call this ABC. All right. What are the 2 rays then? Ray what? Ray BC, which will be this one, and ray BA, which is this one right here. Okay? So they are made up of 2 rays. We got the interior, we got the exterior. This would be right on the ray. We call these rays right here the side. I said rays before, so it meant angle. All right, these are the sides. What does angle B? Somebody said it earlier. This is the vertex. All right, all that kind of stuff. All right, quick little recap on a ray. Or on an angle. I keep saying rays. All right, on an angle. What we're going to do right now is we're going to talk about specific or special type of angles. All right, so there's a lot of special angles, but these are ones that are pretty common. Okay, let's do this. Let's draw one ray like this and one ray like this. You know what? Let's not do that. Let's do this one. Let's do this one first. Sorry. In my notes, I have that one, but I think it might be better if we do this one. All right, that's an angle. Would you agree? Now look, if this goes completely horizontal and this goes vertical, I can put a little box right there. Right, and how do we measure angles? We measure them in what? Centimeters, inches, feet, what? Degrees, right, we measure in degrees. So this would be 90 degrees, okay? So when one is completely flat and one is completely straight up and down, it makes a 90-degree angle. We have a special name, all right? So this is 90 degrees. We have a special name for it, and this is called a right angle. I'll just put the angle symbol. Is that all right? So this is a right angle. That's one of our special angles, all right? What if we had one that looks like, let's see, I got to click off of that. What if we had one like this? Let me ask you a question. Is this more than 90 or less than 90? Right, because if you went this way, it's getting smaller and smaller, right? Getting closer and closer. All right, so that would be less. This is less than 90 degrees. I'm going to write that down. Less than 90 degrees. If you have an angle that's less than 90 degrees, we give it a special name. It's not obtuse, it's acute. These are probably words that you've heard before. You just may not remember exactly what they mean. And this is very important because we're going to refer to these angles all the time. Right angles, acute angles, all that kind of stuff. All right. Now, you did mention obtuse, so let's do an obtuse angle. So what do you think an obtuse angle is? If acute is less than 90, what do you think obtuse is? It's more than 90, that's right. Or let's say greater than. So this angle, see how that angle is more than 90 degrees? All right, so let's say greater than. So greater than 90 degrees. And what do we call that? Obtuse. That's right. It's an obtuse angle if it's bigger than 90 degrees. And we got one more. Watch this one. Let's start here. And I'm going to put a little dot here. Okay, that's one ray. Everybody see that? Now check this out. What if I make another ray going in the complete opposite direction? We could call them opposite rays, but it does make an angle. See that angle right here? If I took that obtuse and kept on going until it made a straight line, how many degrees is that? It's 180 degrees, okay? So this is equal to 180 degrees. It makes a straight line, doesn't it? So what do you think we call that angle? A straight, it's an angle, so we call it a straight what? Straight angle, that's right. Okay, we call that a straight angle. It's obtuse angle, okay? That's really important, okay? It's really important that you know those words because we're going to refer to them a whole lot, all right? See what I want to do. Let's go back to that right angle again. We got another word we're going to use. Watch, if I had a line like this and a line like this, and I told you that that was a right angle, okay? There's a line. These aren't just rays, they're two lines. Okay, but what do they form? Those two lines hit each other. They intersect each other. What do they form after they intersect each other like that? They form a what kind of an angle? What? This is right. Okay, you put the little box there. I didn't even mention that before. Okay, if you put the box, that automatically means it's a 90-degree angle. Okay, you only put the box when it's a 90-degree angle. All right, this has got the box. So what kind of angle is that? It's a right angle. It's 90 degrees, okay? So when you have two lines that intersect each other at a right angle, we call those lines perpendicular lines. You've probably heard that before, haven't you? Perpendicular lines. Like even in sports, sometimes they'll say perpendicular, right? Because if they'll talk about the different angles you take, and they might say, hit them perpendicular or hit them whatever, something like that. Hit them at a 45 degree angle. I don't know. Every once in a while, I've heard coaches use perpendicular, all right? So perpendicular lines. What are their lines that intersect at a what? Right angle, okay? So let's do this. Let's put some points on here. I'll show you one more thing about perpendicular. So here's A, here's B, here's C, and here's D. Okay? There's a symbol, of course, right? We've got a symbol for everything. A symbol for perpendicular, and it looks like this. All right? One straight up and down, and one that goes across like this, horizontally. It's kind of an upside down T, all right? So that's the symbol for perpendicular. So what if I wanted to show that AB, let's pretend I didn't have that little box there. So if I didn't have that box, could you say 100% that they are perpendicular to each other? That makes a right angle? No, you really can't, because that could be off a little bit. It could be like 89.99999 degrees, right? And you don't really know. So we have to be told that they're perpendicular. You could either put the box there, that shows that they're perpendicular, or they could tell you. Again, a lot of times they'll use the word given. So they'll say line AB, it is a line, all right? So line AB is perpendicular. So what's the symbol for perpendicular? It's this little up and down and across one, the upside down T. So AB, line AB would be perpendicular to the other line. What's the other line? You guys lost me? I know I've been talking a lot today. Let's try to stay with me. All right, so line AB and line CD, they are perpendicular. So if you were given this, all right, if that was told to you in a homework problem, what would you know about this angle right here? That's a 90 degree angle. What about this angle right here? It's also 90. Same thing with this one, same thing with this one. All right, all four of those are 90 degree angles. Okay? All right, we talked about a straight angle already. Let's talk about congruent angles. And I really wish we could get done, but I don't think we're going to get done. Yeah, there's no way I'm going to get done, but that's okay. Let's just talk about one other word. This should make sense because we did this with segments. So what if we have congruent angles? What do you think that means? That means we have two angles that do what? That are the same. That have this, not are really the same, but have the same what? Well, we don't really use length for angles. We say measure. Let's say measure. Okay? So watch what I'm going to do. I'm going to copy and paste it. Whoops, thought I did. Let's try this again. Okay, copy and paste. There we go. All right. So I copied and pasted. Let's just call this angle A and just call this one angle B. Here's how I should, you know how we did the tick marks for equal segments or congruent segments? This is what we do for angles. Everybody watch. Almost done. Almost done. Don't pack up. Look, if I put a little arc right here, so if that has one arc and this has one arc, what can you say about those two angles? That they're, well, not acute necessarily. It just means that they are what? Come on. The word's right in front of you. The word's right there. They're congruent. That's right. Okay. They're congruent angles. So what would I say? I would say angle A is what? Congruent to what? Angle B. All right. And that's how you would do that. What if I had another angle that was not, or two other angles that were congruent to each other but not the same as this? Then I would put two arcs like I did with the two tick marks, okay? All right, I'm not going to assign you homework because We just didn't finish. Hopefully we'll finish tomorrow. We'll do part C tomorrow. I tried to get done today. All right, hang on.